Okay, this is 4.4 homework help. This is the first problem. First one gives us a sine function, and it asks for the amplitude and the period. The amplitude is just the distance from the median, the middle, of the sine function to either the top or the bottom, and it's just the absolute value of that distance. So in this case, the amplitude is 3. The period is the distance from like peak to peak, or you could do it from like this intersection point to this intersection point, however you want to look at it. Which it looks like that distance on my graph is just 2 from this point to this point. All right, the next problem gives us a sine function, and we know the amplitude is always here. Our standard form for our sine function is y equals a times sine of bx plus c plus d. So we know our amplitude is 7. The period is always equal to 2 pi over b. So we know our period in this case is, if we know b is 3 pi, plug in 3 pi here, and that gives us a period of 2 pi over 3 pi, which the pi's cancel and give us 2/3. So the period is going to be 2/3. The phase shift is actually kind of tricky, and the reason why is because of the way that this thing is written. I'm going to factor out a 3 pi from this and make it minus 2 over 3 pi. Now you can see that if I were to distribute and go back, if I were to distribute this 3 pi, I'd get right back to what I have here. And the reason why is because then I can isolate x and see what I'm actually subtracting from x, which is 2 over 3 pi. So the phase shift is 2 over 3 pi. And the vertical translation is then down 3. Here's the vertical translation here, as you remember from when we transform functions. Okay, the next problem gives us a sine function, or we could use cosine as well, but I'll do sine. It's y equals a times sine of bx plus c plus d. So the a value is the amplitude, which is 1. B is the period. It looks like this thing goes from, repeats again here at around 6.28, which should, I didn't see this at first either, but 6.28 is about 2 pi. So you can say the period is 2 pi. If the period is equal to 2 pi, we know the period is 2 pi over b. So that means b has to be 1. You can cross multiply, divide, or whatever, and you're going to get b equals 1. So that'd be sine of x. Now this thing is shifted over because sine usually goes through the origin here, because if you look at a unit circle, sine starts off at 0 and then goes up from there because it's the y value. So this thing's been shifted over about this much, which looks like it's about 1.6, which is actually pi over 2. So it's pi over 2 there for the phase shift, so we'll say minus pi over 2. And it's not shifted up or down at all, so this will be our answer for the first one, sine of x minus pi over 2. You actually use cosine as well. For cosine, it'd actually be negative cosine of x. You do that. Cosine and sine are the same thing. It's just that cosine and sine are shifted from each other 90 degrees. And if you're not sure why, look at it. It comes from a triangle. If this is theta, this is 90 minus theta. So call this a and call this b. The sine of theta is equal to call this ab and call this c. The sine of theta is opposite of our hypotenuse, which is b over c. Well, the cosine of 90 minus theta is adjacent of our hypotenuse, which is also b over c. But it turns out that sine and cosine are just complementary. Sine of one angle is the same as the cosine of 90 minus that angle. And that's exactly what we have here. So this is just cosine of pi. And, negative in this case, so it starts off at negative 1. So the next one then is the same thing. It's sine. It's always a sine of bx plus c plus d. The amplitude is 1. Once again, this thing has a period of, it looks like about a little over 6, so 2 pi. If the period is 2 pi, once again, b is 1, because we know the period is equal to 2 pi over b. So b must be 1. And the question is, how much is it shifted over? It looks like sine function usually goes through the origin here, and it's shifted over about this amount. Looks like about a little over 3, so try pi. Looks like it's been shifted over that amount, so we'll do minus pi. It's not shifted up or down at all, so that should work. All right, for the next problem, I'm going to have to do it right on here because to show you how to graph this, but we have 3 sine of x minus 90. Now the regular sine function goes like this. It goes to the origin and then reaches its maximum height at 90 degrees, so that'd be pi over 2, which is about 1.6, 1.57. And then at pi, it goes back to, so the regular sine function looks like this. If you look at a unit circle, starts off at 0, reaches its highest value, because it's the y value here at 90 degrees. At pi, it comes back down to 0. At 3 pi over 2, it's at its lowest value here. There's 3 pi over 2. And then at 2 pi, it's back to 0. And it just keeps repeating. So we just want to shift this thing over 90 degrees, so we just want to shift it over to here. Oops, sorry. So it's going to look like this. So we just need to put those points on the graph. So let's shift this over to, oops, let me erase. So now we start off at 90 degrees, which is about 1.57. And then add 90 degrees to that. So now at pi, which is 3.14, you go to your highest value. This thing has an amplitude of 3. Goes up there. Add 90 degrees again, it gives you about 4.7. Goes back down to 0. And just repeat that pattern. So this is going to, if you subtract 90 degrees, you're going to go down to the lowest point. Subtract 90 degrees, 1.57, you go back to 0. Subtract about 90 degrees or 1.57 radians, and you go up to your highest point. So that'd be up here. Subtract 90 degrees, you go to about 4.7 radians. Negative 4.7 radians, you go back to 0. So if you hit connect, close enough, and hit submit, that should work. Okay, the next problem says the function y equals x squared with the domain. So we're only looking at the values from -3 to 3, which we know what this thing looks like. It's a parabola. But we're only looking at these values, so we're only concerned about from here to here. Has at least one input which produces the smallest output value. Yeah, right here. That input produces the smallest output value. That's there, so that's true. Now the same function with the domain from -3 to 3 has at least one input which produces the largest output value. That's true as well. The largest output value for this function with the domain that we give it would be this point here, 3. So that's true. The function sine now, I'm going to graph sine real quick. Actually, I'll answer 4 real quick because I got the graph up here. This says the domain that does not include the endpoints. These are open circles right here. Has at least one input which produces the largest output. No, because the largest output, we can't include that last endpoint. So we'll say false for that one. And then we'll draw the sine function. The sine function, I'll just do from -pi to pi, so 1 period of this, and I'll put in here then pi over 2, or negative pi over 2 and positive pi over 2. We'll go from -1 to 1. So this thing goes through 0. At 90 degrees to its highest point, goes back to 0. It's at its lowest point here and back to 0. So here's the sine function. Now the function on the domain from -90 to 90 would be this window right here. And we're not including those endpoints, so we would have to say false for that one, because the highest value of the function is actually at the endpoint we're not including, at pi over 2. For 5, the sine function on the domain from -90 to 90 has at least one input which produces. This time we're including those endpoints, so that would be the maximum value. So that'd be true. Okay, the next problem 6 wants us to match these. You can hardly see these, but if you click on the graph, it gets a little bigger. This one goes negative. So we know it's not a periodic function like cosine is. So we know that these two answers have to be these ones. So which makes these two right here. And the negative one obviously has a negative sign here. So 2 would be B. 1 would then be A. And then these two we just have to get right. Well, they're cosine, so they're periodic. One's shifted up and one's shifted down. So let's just look at that feature. This one, C, has been shifted up. So I'll choose C for that one. And I'll choose D for 4. Next problem wants us to take the regular sine function and shift it to the right 8 units. If we did that, we'd subtract 8 from x. 3 units downward, we subtract 3 outside. And vertically stretch, that's multiplying 3 right here. And on our formula sheet, I know that's dividing y by 3, but technically it's the same thing if you move it over here. So that would be vertically stretched. That would satisfy all the conditions that they gave us. That would be our sine function. And they use f of x for this. Okay, the next problem says that it wants to square the sine function The curve goes through these 2 points. If needed, we can use this as a decimal as pi. So here's the graph made a little bit bigger. We can see that the amplitude's 1, so we know A is 1 right here. We still need to find B, and we still need to find D. To find B, we know that the period is equal to 2 pi over B. So we can try to get the period off the graph right here, and then set it equal here and solve for B. So the period's 14 if you use these points that they give you, negative 13 to positive 1. So 14 equals 2 pi over B. We can just switch these two, right, with proportions. So B equals 2 pi over 14, which is pi over 7. So we're going to enter that in right here. And then we need to figure out how this thing's been shifted. Normally the sine function goes through the origin. So it's been shifted over that much, which is 1, 2, 3, 4, 5, 6, 7, 8. So we're going to do x minus 8. And then it doesn't look like it's been shifted up or down at all. So that should be our answer right there. The next problem wants us to find the frequency determined by this equation right here. Now, we know that the period is equal to 1 over the frequency, the reciprocals of one another. So let's just find the period, we'll reciprocate it. The period is equal to 2 pi over b. And so the period in this case equals 2 pi over 91 pi. The pi's cancel, and I get 7 over 91, which I just reciprocate that. 91 over 7 will give me the frequency, and that's in hertz, which is 1 over seconds. Typically it's in hertz. We don't need units for this one though. I'm sorry, this is supposed to be a 2, not a 7. Can't read my own handwriting, so 91 over 2. Next problem 10 gives us another sine function. The amplitude goes up to 4 here, so it would be 4. The period looks like it goes from this point to this point. Looks like the period repeats every 2 radians, so we'll say 2. And then it's shifted over. If we're going to use a sine function, looks like this thing's been shifted over none. Yeah, none, because the regular sine function starts off at 0 because it's the y value, so that's where we want it. Okay, the last question is a little different, but basically here we have a graph of t versus theta, and then over here we have a graph of theta versus point P. It goes around the circle. So as time goes on, theta goes up and then back down, and then over here we have a relationship between wherever theta is, we can find the coordinates for P. So first off, we have what is the value of theta when t is 0.5? Well, when t is 0.5 right here, it looks like theta is about 1.5. And then when theta is 1.5, what are the coordinates of this point? Well, take this triangle right here. I'm going to redraw this triangle over here. If theta is 1.5 and we know the radius of it's 3, we can find the coordinates of x and y. You go over x up y for this right triangle right here. So I can do cosine of 1.5 radians equals adjacent over hypotenuse, multiply both sides by 3. That gives me my x coordinate, which goes right here. For that I got a decimal. I got about 0.2122. And then for the y coordinate, same thing, 3 sine of 1.5 for the y. Sine of 1.5 equals y over 3, multiply both sides by 3. For that I got 2.99 about. So there's our x and y ordered pair. Hope this helps.